main mastery of grade 10 roots and powers is being able to actually combine our exponent laws. We'll be dealing with the 6 that we had done in grade 9, as well as the 2 that we have just learned, where we have rational powers, denominator goes into notch, and our negative exponents, where we deal with taking the reciprocal of our base and then applying our exponent. So dealing with our 6 from grade 9 and then our 2 from grade 10. These 8 all are used interchangeably throughout a lot of things. For example, foundations 20 not necessarily uses a lot of these, but at the same time it may not be touched again until foundation 30. Pre-calc 20 uses all of these in some way, shape, or form in 20, or pre-calculus uses in 20 and in 30. So here's what we're going to do is we're going to do some exponent reevaluations and do a whole bunch of work with that. So when we reevaluate exponents, the biggest thing that we want to do is we want to always write our powers as positive exponents. That's going to come into a huge effect right here, right now. In order to do that, we need to use our exponent laws. Makes sense. So let's simplify using some of our exponent laws here. So x to the power of 5, y to the power of 7, multiplied by x to the power of negative 2, y to the power of 3. Now there's a whole bunch of different ways of doing it. I'm just going to show you 1 or 2 different ways of doing it. It is up to you to work it out. If you feel that you feel more comfortable doing it a different way, as long as it works out, you're all good. Skipping a step is not you figuring out another way. Just looking at a friend's paper is not you figuring it out. Just as an FYI. Okay. So this step for sure, and our first question, this first step is for sure not a necessary thing. So it's just to help emphasize what we're doing. What some people do is they will rearrange their questions. So because it's all multiplication and the order that you do multiplication really doesn't matter. Yes, technically you go from left to right, but at the same time, 2 times 3 and 3 times 2 is the same thing. It's where you have multiplication and division that you for sure have to go from left to right. But I digress. I'm just going to do some rearrangement here. Again, there's people that are able to go from the question straight to the next step in 1 step. That's perfectly fine. So here's what we're looking at. We're looking at x to the power of 5 multiplied by x to the power of negative 2. Well, let's use that first exponent law, product of powers. Same base, we're multiplying, add the exponents. I'm not going to spend a lot of time up here. I'm going to expect that you have these in your memory and are able to use them at a second's notice. Same base, multiplying, add the exponents. 5 add negative 2 is 3. Same base, multiplying, add the exponents. Y to the power of 10. Over and done. Now we have a division statement here. Well, division is no different than what we've been dealing with before. We've still dealt with fractions. For example, our numbers of 5 and negative 10 can still be reduced. 5 goes into 5 once. 5 goes into 10 twice. We can still work with our questions, our parts of this question that have the same base. So in our numerator, well, that 5 is now 1. 8 to the power of 5 divided by 8 to the power of negative 4. Same base, and we are dividing, which means that we have to subtract our exponents. 5 subtracting negative 4 is 9. Now, because we're taking the numerator and subtracting the denominator, that number does technically need to go into the numerator. It'd be 8 to the power of 9 in our numerator. B to the power of 4 divided by b to the power of negative 3. Again, 4 subtracting negative 3 is 7. We still have a negative. Can't forget about the negative, but we still have a 2 there. These two, because we have already combined all of our bases, they're gone. They're already in the numerator. Now I'm going to show you one other way of doing it, because this one becomes really beneficial sometimes. Same time, I might accidentally forget to talk about it on the back side here. So I'm going to just rewrite the question. All right. What do we do with negative exponents? Well, negative exponents means that we have to take the reciprocal of the base. So if by chance we have here this a to the power of -4 right here, it's in the denominator. The reciprocal of something in the denominator means, in all practicality, that base right here, which is a negative exponent, in order to get rid of the negative, we have to take the reciprocal of it. The reciprocal of something in our denominator is actually putting in our numerator, which means that this b to the power of -3, also being in our denominator, the reciprocal of a b in our denominator is actually a b in our numerator. And then continue on. The 5 and -10 still reduce to be 1 and the -2. So we're still going to have the 1. Why didn't I write? There we go. And now that we have a to the power 5 and a to the power 4 in our numerator, same base, and we're multiplying, we add those exponents. Same base, multiplying, add the 4 and 3. We still get the exact same answer, no matter which method we used. So let's deal with some more. Again, this is another one that some people are able to skip steps. I'm not going to rearrange it because I already know that if I have the same base, I'm going to add my exponents. Same base, I'm going to add my exponents. So x to the power 3 multiplied by x to the power of -1 is x squared. 3 adding -1 is 2. Y to the power of -3/2 multiplied by y to the power of 1/2. Well, we're going to take a -3/2 and add a 1/2. Same base, or same denominator, so we can just add across our numerators. -3 add 1 is -2. So we'd actually have y to the power of -1. But as I had said before, we want to write everything with positive exponents. We don't want to have x squared times y to the power of -1. A negative exponent, if it's in our numerator, in order to write it as a positive exponent, all that has to happen is it goes to the denominator. Now, an exponent of 1 is not necessary to write. If you want to write it, great. If you don't, that's fine. So on and so forth. Everyone good? As I ask, intermittent hand. Alrighty. Here's our next one. There's 2 ways of doing it. One is considerably harder than the other. Not entirely, but it's just kind of ugly to work with. I'll show you the easy way first. We have a negative exponent. Well, a negative exponent means we're going to take the reciprocal of the base. That -2 is on the entire outside of this entire base here, which means this b to the power of 1/2 would go to the numerator, and the entire -5, a squared, would go to the denominator. That negative taking the reciprocal of it only gets rid of that negative. It does not get rid of this -5. It does not get rid of the -5. simply gets rid of here. And that 2 stays as 2. You do not take the reciprocal of 2. And you do not take the reciprocal of your exponent. Whew. Okay, and then we can apply our exponent onto each of our bases using that power of a quotient. But what's going to happen here? We're going to have to apply it to this a, but our -5 is also a base. You need to apply it to that -5. Must be done. B to the power of 1/2 to the power of 2. So I'm just going to show this once. I'm not going to show it in the denominator. But 2 is the same as 2 over 1. We have to multiply these exponents, which means it's going to get out to be b to the power of 1. 1/2 times 2 over 1, well, the 2's are just going to reduce. You'll be left with a 1 and 1. You just have b to the power of 1. In the denominator, this -5 is going to be raised to the power of 2. This a squared is also going to be raised to the power of 2. So that's just going to be a to the power of 4. Because power with a power, you multiply those exponents. The last step and the last thing to do is -5 squared is positive 25. If you're typing in your calculator, make sure you put your brackets. I know that they're parentheses, but make sure you put them. If you don't, your answer is going to be negative and then you will lose marks. Be cautious, be conscious. You don't necessarily need to write the 1 as your exponent. Now, the other way that it can be done, which is a little bit more tedious to do, is we can apply that -2. Actually, I'm just going to rewrite the question. We can apply that -2 to every single base right away. Again, it just becomes a little bit redundant to do, but it can be done. So we'd have a -5 to the power of -2. Power of a power, we have a to the power of -4. And we'd have b to the power of 1/2 to the power of -2. Well, that's going to be b to the power of -1. Well, all of these are negative exponents. We don't want negative exponents. We want positive exponents. As soon as we see that there's negatives, it just means that whenever you have a base that has a negative, it just gets flipped to either denominator or numerator, whichever one it's not in. So this -5 to the power of 2, -5 to the power of -2 gets flipped to your denominator. This a to the power of -4, well, that's just going to become a to the power of 4 in the denominator, and this -1 gets flipped to the numerator. Still same work, we still get b over 25 a to the power of 4. Two last examples, and then we can rock. So same kind of principle, same kind of understanding. Well, let's do some work here. We have everything to the power of 1/2. Well, let's simplify first. We have 125. Those are numbers. Well, those can be reduced to 4 and 1. We have the same base. So this, without an exponent, that a is a to the power of 1. Well, a to the power of 1, if we're dividing by a to the power of 5, well, that means that we're going to subtract those exponents. So what we're going to have here is have 4, a to the power of 1 divided by a to the power of 5. So 1 subtract 5 is -4. Because I'm taking the 1 and I'm subtracting the 5, the negative does have to be applied to the numerator. Or sorry, that a has to go to the numerator. The base has to go to the numerator. Again, multiple ways of doing it. Before I go any real further, I'm going to simplify things a little bit. Simplify things as much as I can. For example, these bases, this a to the power of -4 and b to the power of -1/2, well, I'm going to have to apply them. I'm going to switch them so that they're positive exponents right away. So I'd have 4b to the power 1/2 and a to the power of 4, the 1/2, b to the power 1/2 in the numerator, a to the power of 4 in the denominator. Last step, apply my exponent on the outside to every single base on the inside. So we'd have 4 to the power of 1/2, 1/2 and 1/2 will be 1/4, and 4 to the power of 4 and 1/2 would be 2. So last little bit of work is I'm actually taking the square root of 4 to the power of 1, b to the power of 1/4, a squared. My final answer is 2b to the power of 1/4, a squared. Now your assignments don't look like necessarily like this. This is more of a practice question just so that you have the right skills. Usually you don't have a lot of fractional exponents, but at the same time you're prepared for those of you that are going to be taking calculus. You're going to have some fractional exponents, especially when you deal with some derivatives and finding a whole bunch of stuff like that. Calculus talk, but it's all still good. Okay, last example. All of 12 x to the power of -5, y to the power of -2/3 to the power of -3 divided by -6x squared, y to the power of -5. Well, before I do anything, I see that there's an exponent just on the numerator. That -3 is not on the denominator. I'm going to have to do some stuff with my numerator before I can even do anything with that denominator. I'm going to have a 12 to the power of -3, because that -3 is going to have to be applied to every single one of my bases. And then I can continue. -5 times -3 is 15. -2/3 multiplied by -3 is +2. I'd be left with that -6 x squared y to the power of -5. That's in the denominator. My next step is to see, okay, I have this 12 to the power of -3 in my numerator. Well, a negative exponent means it should be written as its reciprocal. If it's in the numerator here, it should go to the denominator here. I can take my x to the power of 15. So I'm just going left, top, bottom, left to right. So I've done this one. X to the power of 15 divided by x to the power of 2 is x to the power of 13. Y to the power of 2 divided by y to the power of 5 is y to the power of 7. 2 subtracting -5, 7. I'd still be left with that -6 in the denominator, but these ones are already gone because I've already combined them with my numerator. So I'm going to have x to the power of 13, y to the power of 7. Let's see, 12 cubed is 1,728 multiplied by -6. I would get x to the power of 13, y to the power of 7 divided by a -10,368. And there we've combined all of our exponent laws to give you some practice. So go have fun.